All right, so today we're going to talk about 5.4. This is your homework for the weekend. And the main goal here is to come up with some formulas for using an infinite number of rectangles to find a way to come up with a precise definition for the area under the curve. Okay, that's our main goal. So we're going to use the summation notation to actually evaluate the area under the curve. So starting number, ending number, and whatever our function is. Okay. Important thing to note here is this symbol here is called sigma, and it means to sum things up, to add them up. Okay, so here's some examples that we would have done in pre-calc. We have a number starting at number 4, and we're going to perform this operation on it. And we're going to do that for all numbers from 4 to 8. And so you can see it there, then you would just add them up. Okay, so if we look down here, we're starting at number 1 and going to number 5. Okay, so we're just following a process, and then you would just plug that into your calculator and come up with the sum of that series. Okay, so now we're going to take the idea that we have summation notation, and you can change the numbers or the limits and write it in a different way. For example, if we take this pattern for 1 through 5, we can take these 5 numbers and we can write them in this pattern using different start and end, or this pattern, different start and end. Okay, so there's more than one way to come up with writing the summation notation. Okay, so here are some properties, a couple, and we're going through this kind of quick. They're in your book. You can take a look at them. A constant that's inside can be moved outside, hence it's outside. You can take something that's either plus or minus, and you can separate that into 2 separate sums, plus and minus. And the reason we want to do this is so that we can actually utilize the formulas here. So if we can follow one of these 3 patterns, we can use one of these 3 formulas. And again, we're just using the pattern. And so we want to be able to write that and solve for that using our nth term formulas, and then we can just plug in and solve. A lot of calculator work in this section. Okay, so let's just evaluate. So I'm going to take this, and the first thing I'm going to do is I'm going to distribute, I was going to say FOIL, but I'm going to distribute, and then I'm going to separate it into 2 summands. And then I can plug into the formulas from the previous page. And I can do some calculator work. And so I'm going to go ahead and just do that now. So 5 times 31 times 61 equals 5 times 31 times 61 equals, and I get this number. And then I get 15 times 31, and I get this number. And when I add those together, I get this number, 9920. Okay, and that is in fact the answer to this. So this equals 9920. Okay, so all we're going to do is use our calculator, plug into the formula, and hopefully get the correct answer. Hopefully, assuming we haven't made a mistake somewhere, and we get the right answer. Okay, so the second thing we're going to do now, and I'm going to want you to pause this, you're going to express this in closed form. And what that really means is give me an explicit formula. Okay, so this is just basically taking the k and writing it in terms of n. And so I'll just write out a couple of numbers so we can get the pattern. If I plugged in 1, if I plugged in 2, if I plugged in 3, if I plugged in 4, all the way until I plug in n, in which case I'm going to get 3 plus n quantity squared. And so that's my pattern. But the explicit formula says you got to come up with a method where all you have in there is n's and a number, or k and a number. So I want to go ahead and say, okay, I'm going to convert this all to k's, so to speak. And so what I want to do now is I want to say, okay, let's pretend for a second that I started at 1. So 1 squared plus 2 squared plus 3 squared, because I want to have it be from there, okay? In fact, I think I might have used the wrong letter there. No, I'm okay. I want it to be k. And so if I do this, in order to get this same pattern that I have here, I would have to actually subtract out this. Okay, so let's go back up here for just a second. I'm looking right here. See how this series started at 4 squared? In order to close it, and starting at 1, what I'm doing is I'm actually adding in these 3 extra terms so that I can stay starting at 1, but I want to end at 3 plus n. So I literally want it to end at 3 plus n. That's my last term. So instead of saying n, I want it to end at 3 plus n, which is my last term. So I'm going to change the n on top to a 3 plus n, because that's what this formula is saying. And so that means I have to add in these extra terms. Well, I can fix that by just subtracting them here. And so if I do all of this, then what's going to happen is I'm going to end up canceling everything out except for what was originally this minus 14. Okay? So here's what we're saying. Here's what we're saying, kids. If we did this all the way till we got down to here, to 3 plus n quantity squared, then I could keep doing that, and then this should be here. I should have a plus, and I should make sure you see this. 3 plus n squared, right there. 3 plus n quantity squared. And so now what I want to do is I want to pull out everything, and then just be left with this. That's really, now I have a formula that I can use. That's the only reason we do this. And for all intents and purposes, we do this very little. But we want to be able to do it so that we can use the formula. The whole goal of this is to use the formula. You would never be asked to do this process on the exam, okay? But we want you to know where it comes from, because the whole goal is to be able to use the summation formulas, okay? So in order to have it work, now when I plug in 1, I get 1 squared minus 14. This minus 14 here, that's the number that I had to get rid of, because that's the number that I added in here, okay? And again, we only did that so that I could come up with a closed formula, so that this 3 plus n, which is what I ended up with when I did it up here, that becomes my last term. So 3 plus n is going to become like my k. That's like my k. So the only way I can make this be k squared is if I started at 1, and so that's why I'm adding in the 1, 2, 3, quantity squared, quantity squared, quantity squared. Okay? Don't worry too much about that one. Okay. So our goal is to get to here, where we can find the region under the curve. Okay? So when we do this, we have lots of options. We're going to draw in these rectangles, and we have the first rectangle, second, third, so on. The more rectangles we have, the more accurate our area, okay? So these are picking arbitrary heights. You will always pick one of 3 options, a left, a right, or a mid, okay? We're going to talk about this f of x star k. This right here, delta x, is going to become your base, okay? B minus a over n. N is the number of rectangles. And remember that your interval notation is written like that. So you're really looking at your left and right balance for your interval. Okay, so the area under the curve. I'm going to keep it simple, stupid. This is our base. This is our height. How do we finish up? These are y values. This, remember, is our b minus a over n. But now instead of doing it for 4, 8, 10, 20 rectangles, we are going to do it as n approaches infinity. Okay? All right, so let's do an example and see what happens. We want to use the right endpoint. Oh, my class, we did this one today. Use the right endpoint. I got the right answer. Okay, so the right interval. So we're going from 0 to 1. This is A, and this is B. So our delta x, is our base, is equal to b minus a over n, which is equal to 1 minus 0 over n, which is equal to 1 over n. Okay, so that's our base for every one of our rectangles. And I'm just going to put in a little quick sketch here. That's y equals x squared from 0 to 1. So we're looking for this shaded region here. Okay, so right-hand endpoint means my f of x star k means I'm going to take a look at the right hand 0 plus, oh, my right, Miss Collins, you silly goose. Miss Collins is a silly goose. Because right hand endpoint, I prefer left, can you tell? This is my right. This. Okay. So now I have my right hand endpoint, and every time I make a new rectangle, I'm going to be moving to the left. Notice that it's my right corner of my rectangle that's actually touching the curve. Okay, I don't know how many rectangles I drew. It doesn't matter. But here's the key point. This is the right corner, right corner, right corner, right corner, right corner. So let's just say, for example, I know how wide it's going to be. It's going to be 1 over n, right? That's my base. So to find this right-hand endpoint or this right-hand endpoint, every time I do it, I'm going to subtract, so 1 minus 1 over n for the first one. To get to the next one, it's going to be 1 minus 1 over n minus 1 over n. To get to the next one, it's 1 minus 1 over n minus 1 over n minus 1 over n. Okay? So for my first rectangle, the very first rectangle, the bound is just 1. For the second rectangle, so this is x of k, which is x of 1. That's for the height of the first rectangle. That's the height of the first one. Then the height of the second one is this. And the height of the third one is this. And the height of the fourth one is this. And so we want to come up with a number that will give us the bounds. Now, there are formulas in your book. I like to show you where they come from. The formulas in your book are actually on page 345, page 345, page 345, page 345. And what you're going to do then is you're going to use the right-hand endpoint, which is on that page is the middle formula 4. And so what we want to do is we want to say, okay, well, looking at that, what's our A? Our A happens to be 0. We're using the right-hand endpoint. A, oh, it does it different than I do, plus K delta X. So, I do it different. That's great. So A is there, plus K delta X. So K times 1 over N. I like using the other formula, but we'll go with this one because it's 0. Okay, so once I have that, I need to find f of k over n. So what I'm going to do is I'm going to take f of x, which is equal to x squared, and I'm going to plug in k over n. And when I do that, I get k squared over n squared. Okay, so once I have k squared over n squared, remember this is going to be my height. Okay, so now I have my height, and I'm going to say, all right. Oh, base times height. I lost my head for a second. It happens. Base times height. I know why. So what's my base? My base is 1 over n. And now I'm going to, oh, I know why. Oh, just let me fix this for a second. This needs to go away. This should go away because that's throwing me off now. Because they went 0 and they just went across 1 over n. Across 1 over n. Got it. Okay, I'm with it now. Okay, sorry, detour. And then my height is going to be k squared over n squared. And so I'm going to sum this up from k equals 1 to n. And so what I end up with is 1 over n cubed k squared. And I'm going to take the limit as n goes to infinity. And if I do that, there's a formula. You just wrote it down. It's on the previous page in your book. It's actually going to be on page 346. And on page 346, it says that this thing right here has a value that's actually equal to 1/3. And that's what it says. That's on page 346. Okay? So this is just a direct substitution from page 346. But it says, hey, by the way, from 0 to 1, the area under that curve is actually equal to 1/3. Now, theoretically, you pause right now, you should be able to check this on your calculator. Mr. Quinton's class, you know how to do this as well. Go to your y equals, and what you're going to want to do, turn off Mr. Wood's stat plot. You're going to want to just enter your x squared function, and then second calc, 7, and your bounds are going to be from 0 to 1. So if you're using your calculator, you can do this easily too. As soon as I fix my window, I'll be there. I want my window to go from 0 to 2, just because. And now second calc, 7. My bounds are from 0 to 1. And magical, you get 0.33333, which is in fact exactly 1/3. Okay? All right, let's do the next example. This one is using midpoint. This one's using the midpoint. And now we're going to use a different formula. So f of x is equal to 9 minus x squared, and we want to do it over the integral 0 to 3 a b. So the width of each of our rectangles is going to be b minus a over n. I call that my base. You can call it your width if you want. And that's going to be 3 over n. Okay, so f of x star k implies that we know what our x star k is. And again, for all intents and purposes, right now, I'm just going to go ahead and tell you, look at the formula on page 345. The one that says midpoint uses the following formula. If I'm not mistaken. Okay, minus 1/2. Not bad. Because you only want to go half that distance. Remember, half that distance. And that's where the 1/2 comes from, because we're going halfway. And so now we want to plug in. So the first thing I want to do is figure out what my x star is. So this down. So my x star k, using my midpoints, my a is 0. And my delta x is 3 over n, which is going to translate to 3k over n minus 3 over 2n. And so now I want to have f of 3k over n minus 3 over 2n. And that's going to be 9 minus that thing. Oh, heavy algebra. Oy vey. Squared. And in case you haven't heard my whining, I'm not a fan of the midpoint. Okay, let's FOIL. 9k squared over n squared minus 9k over 2n squared minus 9k over 2n squared minus plus 9 over 4n squared. And combining like terms, 9 minus 9k squared over n squared plus 18k over 2n squared minus 9 over 4n squared. So I had to distribute the minus sign. Okay. And then this right here is only my height. Woohoo! Don't you love Algebra 1? So let's take height times base, or base times height, or height times width. And we're going to now take this 9 minus 9k squared over n squared plus 18. By the way, while I'm rewriting this, I don't doubt that I have a dropped minus sign or a missed term. So I'm hoping you're checking me and not just assuming that she knows what she's doing. Please don't assume that. It's highly unlikely that she knows what she's doing. With this 3 over n. Okay. N, not 2. I put n. Silly. Okay. So now let's distribute. 27 over n minus 27k squared over n squared plus 2, 4, 54k over n cubed. Ooh, bad. Bad, Miss Collins. That's an n. Let me see. 18k. Check my algebra. No, it's 2n squared. Okay. 18k over 2n cubed. And then minus 27 over 4n cubed. And now I want to use some formulas. And so we want the limit as n goes to infinity. So I'm going to pull out the n's, and then I'm going to have 1 over n minus 1 over n squared minus plus minus okay. And so coming up here for a second, what I did here was I had 3k over n minus 3 over 2n, and I multiply that by 3k over n minus 3 over 2n. And when I do that, top to top, bottom to bottom, since it was fractions, I'm going to get 9k squared. I'm double checking my math. 9k over 2n squared minus 9k over 2n squared plus 9 over 4n squared. Correct. So far, so good. And when I combine like terms, these two combine, so I got the 18, but then this minus sign has to distribute. So this was plus becomes minus, these two minuses become plus, this plus becomes minus, and that equals my height. So that's the 9 minus x squared. Okay, that's the x. Okay, that's my x. Lots of algebra at you. Okay, so now here I am, and I want to use the formulas that I have. Because if I don't use the formulas I have, then I have a dilemma. So the formulas that you can use are on page 346 and or, I'm flipping back, 343. So 346 or 343. And so a couple of things to note about the formulas. In this case, that's a constant. So when I do the summation notation there, I'm going to run into an issue. Here, I'm good, because I'm going to end up with 1 over n times, and this one's on page 346. which says if this is a constant, I can just switch this out, and it's just this. And when I have 1 over n squared, I'm going to end up with the 1 over n squared. That should be a k, but I have a k squared. So what I want to do is I want to say, okay, 1 over n squared, and I want to say that's going to be times 27. But that's also going to be times by the formula for k squared, which is n times n plus 1. And this formula, just so that we're all on the same page, let me point it out to you. This formula is on page 343. And then you have a 2n plus 1 all over a 6. Then you have a 1 over n cubed times 54 over 2. And the formula for k is n times n plus 1 all over 2. And then the formula for the constant here is negative 1 over n cubed times 27n. Because that's just the constant. Okay, that's just the constant. Okay. Wait, did I say that wrong? Hold on 1 second. I did. If that's a number, it should just be the number. So let me erase that in. Okay, there we go. All right, so now I have to do some good math, and so I need to FOIL out a bunch of stuff. So let's FOIL this out. This is going to be n squared plus 1, 2n plus 1. So n squared plus n. So 2n cubed plus 2n squared plus n squared plus n. And that's going to give me 2n cubed plus 3n squared plus n. And that's going to be times here. 2n cubed plus 3n squared plus n. And that's all over. Oh, I pulled the 6 out already, so I'm okay. And then the next term is going to be plus 1 over n cubed times 54 over 4 times n squared plus n. And then the last term is minus 27 over n cubed. Oh my gosh, this is so ugly. This is 27 minus 54 over 6 plus 3n squared over 6n squared plus 27. Ooh, this is silly girl. 27. So 27 times 3, 81. N squared over 6n squared. 27n squared. I'm sure there's an error at this point. Minus, boy, no, plus 54 over 4n cubed times n squared plus 54n over 4n cubed minus 27 over n cubed. Okay, so the one place I think I have to double check. So this gives me n squared plus n squared plus n, and I'm going to multiply that by 2n plus 1. So I get 2n cubed plus 2n squared plus n squared plus n, and that's all over 6. So I pulled out the 6 and the 27, and the 6n squared is here, and then this becomes 2n cubed plus 3n squared plus n. So far, so good. Okay, and now we're going to, again, here we go, we're going to let the limit and then goes to infinity. And we're going to see what we have left. So let's do some math, and we're going to say, okay, if n goes to infinity, what do we have? So So let's do that. We get 27 here. I'm going to come back to this one. So plus, those cancel. First off, let's reduce. Gone. Gone. Okay, so back in pre-calc, if in fact we run into an issue where we were running into a problem for horizontal asymptote, it was section 11.4. We took the limit as n to infinity. That number is going to be gone, 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 gone. So we want to get rid of everything that doesn't exist. And so we want to figure out, okay, well, let's figure out where we're at. We want to go from 0 to 3. Let me check the answer here, because I think I have an algebra error. Okay, so we're getting rid of everything. So as n goes to infinity, these things are going away. So I have this plus number here. What's 81 divided by 6? I'm using my calculator now, because I want to know what 81 divided by 6 is. So I'm going to move this up. I don't want a decimal yet, actually. So okay. 81 divided by 6. Oh, well, this is going to be 9. I think this is huge. So that's that. And this is this. I don't know why I did that. That's 0. I think I dropped a number somewhere. So 54 divided by 6 is 9. So 27 minus 9 plus 0 plus 0 plus 0 plus 0 plus 0 plus 0 plus 0. And all of that goes away. And guess what? Final answer is 18. Okay, so let's come up here. So we did all of this work. I hope you're not trying to follow that. That is atrocious. Okay, so that becomes our x star. Once we have our x star, we plug that into f to find our height. I'm talking you through this again so you can see where we're at. Once I plug that in for my height, I come up with the final answer that represents my height only. I then take that number, and now I'm going to multiply that by the base, which is 3 over n. Oh, okay. So then I get this k squared over n cubed. Oh, that's where I dropped it. See, I had dropped it somewhere. Okay. And so once I have that, then I can go and do all of the algebra from there down. This should have been an n cubed. See, it is very difficult on this board to keep all of these things straight. So if you're trying to follow that, that's why I put it here, because I knew it was supposed to be cubed. So my bad. It gets super messy and ugly and long, so please, please, please show all of your work, because it is super ugly. Okay, so numerical approximations, a couple of things. Left-hand endpoints uses the left corner. Right-hand endpoints uses the right. Midpoint uses halfway between the edges of your rectangles, okay? That's all you need to know. All right, find the left hand, the right hand, and the midpoint approximations for the area under the curve. Y equals 9 minus x squared over the interval 0 to 3 with n equals 10, 20, and 50. Okay, so I'm not going to do all three. I'm only going to do one, and I'll do one from each left, right, and mid. So I'm going to start here. We'll do the left hand, and we'll do the mid, and then we'll do the right hand. Okay, so if that's the case, our A, so 0, 3. So we're going to have 3 over n is our base. And that's going to be in every case. In every case, our base is going to be 3 over n. Okay. The second thing we want to do is we want to take a look at the left hand. And the left hand says you're going to take your A and you're going to add a width to that. You're going to add a width to that. but you're going to add one less width every time. So you're going to have A plus K minus 1 delta X. Here your X star is going to be A plus K delta X. This is delta X. This is delta X. This is delta X. For your midpoint, you're going to start with your A value, but you're going to subtract a half of that every time you do it. So my A is 0, which is nice. So I'm going to have K minus 1 times 3 over N. Here I'm going to have K minus 1 half times 3 over N. And here I'm going to have K times 3 over N, or just 3K over N. 3K over N minus 3 over 2N. And over here I'm going to have 3K over N minus 3 over N. Now I need to plug those into my formula. 9 minus plug that in. And plug this in. Oh, look at this one's my favorite. So this one's super easy. 9 minus 9K squared over N squared. I did that one in my class. I think I called it left hand, but that's the one. 9 minus, and it won't matter, by the way, if you do the limit. It doesn't matter. And then this side is going to become 9K squared over N squared minus 18K over N squared minus plus 9 over N squared. So we get 9 minus 9K squared over N squared minus plus 18K over N squared plus 9 over N squared. And I'm going to take that height and I'm going to multiply it by the base, which is 3 over N. So I get 27 over N minus 27K squared over N cubed plus 54K over N cubed plus 27 over N cubed. I'm going to cheat here for a second, and I'm going to let you know that you can pretty much wipe away these two terms right here because the degree of the top is far less than the degree of the bottom. The other two, however, are going to work out quite nicely, so we'll deal with those shortly. And so the formula 1 over N, if you have a constant, right, so we're just going to have the number 27 of those. And then I'm going to have minus 27 over 1 over N cubed. There we go. And then this formula. Then I'm going to have plus 54 times 1 over N cubed of this formula plus 1 over N cubed of, times 27. Okay, so if I look in my notes, again, you should be flipping back and forth in your pages. If you haven't memorized these formulas yet, I keep looking back at them just because it's helpful to have. And if I do this, on this one, this is a direct formula, I end up with 27 times 1. Okay? If I do this one, gone. If I do this one, minus 27, this one has a formula that says n times n plus 1 all over 2. I get 27 minus 27 n squared over 2 minus 27 n over 2. Oh, this column's be silly girl. I used the wrong formula. My bad. See, this is why we have our books handy. This is 27 times the 4 over n cubed times the formula for k, which is n times n plus 1 all over 2. And then plus 27 over n cubed times 1. And now we want to take the limit as n goes to infinity. So this is going to become 2n cubed plus 3n squared plus n. So I get 54n cubed over 6n cubed. And everything else is going to fall by the wayside. I'll show you here in a second. Oh, this math is killing me today. I'm going to die. Plus, and this is all going to go away again. Because I let n go to infinity. Remember, I'm always going to be letting n go to infinity. And if we remember our pre-calc, if the denominator is larger than the numerator in terms of degree, then it's going to go to 0, 0, which, by the way, this is our last two terms, which I told you up here, these two terms would go away, wouldn't even count. Gone, gone. So I'm going to end up with 27 minus 9, which I believe we just did earlier, and we got 18. But now, as Miss Collins is standing here looking at these notes, she realizes, Miss Collins, you big old jack. I'm so sorry. I did not follow the directions, Miss Collins. I let n go to infinity. And guess what? I'm supposed to do n equals n 20, 50. And I don't want to do those. So if you're in my class, say hallelujah right now, because that's the only thing I'm going to make you do. I won't ever make you do it with n equals 20, 10, 50, or 100. Who cares? And if you're in Mr. Clinton's class, you can just tell him that Miss Collins did the first one and then realized she had missed the directions, because he's probably not hearing this right now. Okay, net signed area. If the function is continuous on a, b, closed interval, then the net signed area between y equals f of x and the interval blah, blah, blah is this. So Miss Collins, that's what I was just doing. So what you want to do is notice that this is all positive, this is all positive, and this is negative. Okay? So if you added up all these red rectangles and all these blue rectangles and then these red rectangles, your net would be red rectangles, red rectangles. That's your net. Your net means your gross amount, whatever you have left at the end, right? Okay. Your net amount, not your gross. Your gross is what you get before taxes. This is your after tax. All right, confirm that the net signed area between the graph of f of x equals x minus 1 and the interval 0, 2 by using the definition chosen with the left endpoint. Okay, so I know this curve. I am not, hint, 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 I'm a rule breaker, not a Mr. Clinton. I'm going to confirm that the net signed area is 0. And the way I'm going to do that, I'm not even going to use this definition because I like to keep it simple, stupid. If this is true, if I plugged in 0 here, this right here is a negative 1. I'm already told that this is 1. I'm already told this is 1. If I plug in 2, I get a height of 1. Base times height divided by 2. Base times height divided by 2. Negative 1/2 plus 1/2 equals settle. Now, if I want to do it the long way, which I do not, I want to say that my b minus a is 2 over n. And I want to know what my x star is, which for left endpoint is going to be a plus k minus 1 times the distance here for each width. So that's going to be 2k over n minus 2 over n. And that's going to be equal to 2k over n minus 2 over n minus 1. And I want to take that, and I want to now multiply it by my height and my base. So this is my height, and this is my base. And I'm going to get 4k over n squared minus 4 over n squared minus 2 over n. And then I'm going to use the formulas. And the K formula says n times n plus 1 all over 2 minus 4 n squared times 1 minus 2 over n times 1. Those are my formulas. And if I do that, then I end up with 4n squared over 2n squared plus 4n over 4n squared over 2n squared, and then 4n over 2n squared minus 4 over n squared minus 2 over n, and that would be 1. Oh, 1 over n. 2 times 1. So the formula needed the n, so that's why I took it out. Okay, and now this goes to 0, and this goes to 0, and this becomes 2 minus 2, and you get 0. So the formula that I used here, where it was 2 over n, oh, I erased this. This right here, where it was 2 over n, this formula is really 2 times 1 over n, 1. That's what we're really looking at, okay? And so that's on page 346. And so that's why I didn't write the n here. That's how I got to here. That's just one. Okie dokie, artichoke, and you get 0. I preferably prefer you recommend and highly recommend that you go with basic geometry when at all possible. Okay, so now you're going to do the quick check exercises. Hint, hint, we are not going to make you do it for 10, 20, 50. We're just not going to do that. That's not expected on the AP exam. You don't have time. However, 4 subintervals using left, right, and midpoint is absolutely used on the AP exam. Okay, so this is on page 350 in your book. The answers are on page 352. Good luck, and I hope you have a good weekend.